Hello guys, in today's live stream we will work on our brain tumor data set. Let me open the Kaggle problem. So I have so I already mentioned this in my this YouTube video description. So we have this problem that this is brain tumor. We have different brain tumor images. We have four normal, if you can say, four directories. One is a glioma tumor, another is a meningioma tumor, third one is you can say normal image, and fourth one is pituitary tumor. So let's read this about about the dataset introduction. Open data source. Remove. So all images are already resized, so we do not need to resize these all images. So let's start working on this data set. So we need to start our session using TPU, or you can say GPU. Let me stop this up. We will use GPU T4X2. Here, let me change the notebook name. Brain Tumors Classification. Okay. So let's start with our problem initially. Let me create a markdown data set link. Also, I downloaded this, you can say data set, and save this in, you can say, in my this brain tumor classification. So here, let me initialize my git. So we will paste our, you can say, we will download our this Kaggle notebook and paste it to this directory. So initially we oh, so this is a code cell. Let me create a markdown. Importing, you can say necessary. Libraries. So first we import numpy as, and or we can also before that can also import warnings. We will give this in. You can say import pandas as pd, import matplotlib.pyplot as plt, import cbone as sns, and then we will import our, you can say, os. Then we will after your os we will import warnings. So we will ignore all warnings. For that we will use war warnings dot filters. Oh no, it is filter warning, I guess. Filter warnings. Here you can see. Here we will mention ignore. Now we will import cv2 for image, you can say, loading. Then we will import TensorFlow. Import TensorFlow as tf from from TensorFlow, import keras also from TensorFlow.keras.callback. We will import our, you can say, early stopping. So it is, I guess, instead of callback, it is callbacks. Let me Google it. So it is callbacks. Here it is callbacks and it is early stopping. Let me run this command. You can see we loaded all our, you can say, libraries. Now let's so this is our input directory. In this we have os.list dir. Here we will give the address and then you can say we will give print, and here we will mention the type. It is Roma. glioma tumor. And now let me copy this entire thing and meningia, meningioma, meningioma, meningioma tumor. So, and third one is our normal. So, so this is our pituitary tumor. Okay. So all these image are reshaped. So let's load these images. OS dot list. And let me print file. Let's see we get these phonemes. Yes, we are getting. So what we will do here, we will define, you can say, x and y as empty list. Okay, so now we will load all images to x and all labels to y. So for that I have to get inside this for image in os dot list, and then I need to copy this plus string file. Okay, and then I have to use img is equal to cv2 dot im read. Then we will give this, you can say, then plus in string form we will mention our image. Okay, then we append inside this X, append the file name. Okay. So let's try to do that. So here we have to mention slash. Okay. Here also we need to add a string which contains a slash. That's all. So its shape should be around. Let me open the calculator. 901 plus 913 plus 438 plus 844. So we have around 3096 images. Now x is equal to np dot array. Let me convert this into array also. Also to np dot array y, and let's check its shape. Here you can see, and also let me check. Okay. Okay, for so let's, you can say, print the image pltx. Our x will be off, and plt.im show, we need to give an image. Let's do it 52. You can see. Also, let me so we have to, you can see these all values are from 0 to 2, you can say 255, 255. So we need to normalize this all images. So for normalization we have to do just nothing. We will define new variable that is x scaled is equal to x divided by, you can say, 255. And now let me show you. Here you can see all values are converted, or you can say converted, or you can say normalized from 0 to 1. So now let me do one thing also. Let me check my y. Now we need to convert this into, you can say, categorical values, or you can say we have to perform one hot encoding to this. So for that we need to import so for that we have to import our label encoder from scikit-learn dot pre-processing. We have to import our label encoder, or it is in, let me check. So it is in pre-processing label encoder. Okay. Let me define one hot encoder as label encoder we will save this in y underscore oh is equal to y dot fit transform. Oh, instead of you can say y, we have to give oh dot fit transform. Let me fit transform. Here we have to give our, you can say, y, and then I guess we need to give the shape. Let's run this. So here you can see. Let me define this in, you can say, data frame. Here our data is you can say y underscore OHG. Let's dot a value count. It is value counts. So here you can see. And one more thing, we have to add random state also. So that in it you can say one hot and cold in the or I have to give this. So glioma tumor mapped to 0, then glioma tumor mapped to 1, and no, okay, so normal is mapped to you can say 2, and you can say uterine tumor is mapped to 3. Okay, so now we have to convert this, you can say YOH2 categorical, you can say into categories to categorical data. Let me define a new defined variable ycat as, so here, so we defined keras dot utils dot to categorical. We have to give our YOH and then a number of classes. YOH is our, you can say Y and then let me see, comma num plus is equal to 4. So let's see ycat. So here you can see this is one hot encoded. Now what we will do, we will now we are splitting our data into training and testing set as extreme. Before that we have import from scikit-learn dot pre-processing. I guess it is in linear model. Import train test split. So it is in pre-process. Model selection. I'm really sorry. Model model selection. Then x train comma y train. Oh, well, sorry. X test comma y train comma y test is equal to train test split. Here first we have to give our x. X is our you can say x scaled, x underscore scaled. Then y is our y underscore cat. Then our you can say test size is 0.2 and random state we can give 21. Let's check dot shape. So here we have 320 images. Let me check the stream. So this is so also let me check my white test also. Okay. So let's try creating our model. Creating our model. So we will define it as model is equal to keras dot sequential. Here we will add our layers So first we will add keras dot layers dot conventional convention 2D. Here we will give filters is equal to 32. Then we will define kernel size 3. Then activation is we will take this as relu, and our input shape is equal to, so it is 256 cross 256 256 comma 256 comma 3, and then move towards our next layer, that is max pooling layer. Keras dot layers dot max pool 2D. Here our pool size will be 2 comma 2. Then here let me copy this entire code, and so here filter size will be 64, and we have to remove this input layer. So here we will define as filters 128. Let's create you can say we have around 1 2 3 4 5 6 7 8. Let's create it for 10 layers. So here we will add a dense layer, or before dense layer we have to add a, you can say, flatten layer for converting this into a one dimensional, you can say, in converting this data into 1D. Layers dot dense. So here we have 4 different categories, and our 4 different categories we have to use activation as we will use softmax. Let me cross check it. In my opinion, we should use softmax for a multi-class classification. Yes, we will use softmax activation layer. And now let me compile my model. For this we have to give optimizer as Adam optimizer, and loss as categorical class entropy cross entropy. I guess yes, for a multi-class we use categorical. Yes. So this is our, you can say, loss function. Now comes you can say matrix. It will be, you can say, accuracy. we have to give you can say comma. So now we are training our model. Also before that we have to you can say add a early stopping. Let me add that early stopping here. ES is equal to uh, so yes we imported early stopping. Yes here early stopping we have to monitor you can say well accuracy mode will be max and then 4 you can say efficiency equal to 5 restore let me for a second cross check. So I guess I used early stopping here. So let me check how we defined early stopping here. You can see restore best rates is equal to true. And then for you can say model dot fit what we have to you can say define model dot fit we have to train on x train then y train approximately 50 yes and then validation data split will be 0.20 so you can say from x train and y train we get we will use 20% data for validation and 80% for training. So batch size will be 32 and callbacks or you can say replace stopping is yes. Let's start with our model. Let's see. So here our accuracy score is increasing. That's nice. So here you can see we reached around 97% accuracy for X test. I am sorry, for X train. And for validation we have you can say 84% accuracy. So here it is stopped because in you can say last 5 layers we are getting around same accuracy. So now what we will do, we will predict for X test. Y pred will be is equal to model dot predict for X you can say test. So we will get I guess array. You can see now if we give np dot argmax and then we'll give our you can say value. Let's see. So here I use argmax in my you can say notebook. Let me check how we have to give this out. Also our axis will be 1. Okay. Here we have to define axis also. Here you can see. So this is our you can say prediction. Or we can say it as y predicted. And then we can match this with you can say where is our y. Okay, so we have to do same thing with our y test also. np dot array or instead of array we have to do argmax y test comma axis is equal to 1 and you can see get the value now. Here let me give this as byte true. And now let's create a you can say accuracy score. Let's calculate accuracy score using model dot or we have to from scikit-learn dot matrices. Let me import classification. We have accuracy score. We need to import confusion matrix also. Also a classification report. So our accuracy score will be, first it is y2, okay, then y predicted. So here you can see we are getting around 87, or you can say around 88%. That is 0.88 score for this model. Now let's create a classic, or you can say confusion matrix. SNS dot heat map. Here our data will be, you can say CM and annotation is equal to true, and then FMT will be, you can, format will be dot 0f, and then we have to dot show. Before that, let's give a title, create dot title as confusion matrix. Here you can see we get a nice confusion matrix. So it is confusing between uh, in 0 and 1, in category 0 and 1, and 4, 1 and 3 also. Let's create a classification. Classification report, and for classification report we have to do print classification report. First we have to give our white true, after that we have to give y predict. So it is y predicted. So here you can see we are getting good results for, you can say, category 3, category 2. We are getting less score for, you can see, category 1. So category 1 is, you can see, meaning glioma tumor. Okay. creating now let's creating a new model with two more convolution layers and two more you can say one is the pooling layer. So here we copied to it is 512. Also we have to define this as model 1. I'm really sorry, forgot. We have to fit our model 1. Let's start fitting our model 1, and as it train, let's and after training this model we will train it using VGG16 model, you can say using pre-trained model. You can see our training is finished. So let's predict for, you can see, and this time we have to use model 1. So here you can see our accuracy results are dropped here. This time it's get in previous confusion matrix 16 23 11. So in the 17, 26, 10. So in this case, in this training, our model is confusing more between 0 and 1 as compared to our previous one also. Let's try, you can say, a pre-trained model, and then we will see. That is BGG 16. So let me from tensor flow dot keras dot applications, we have to import VGG16. I guess after applications we have to use VGG16. Let me check. Yes, we have to. Let's import VGG16 model. It is imported. Now we will define as VGG16. VGG16. Here our input shape is 256,3. Our weights will be ImageNet, and we have to delete our top layer, so we have to include top is equal to false, because in top layer we have, you can say, 16 different categories, but we have to train it for 4 different categories. That's why for layer in VGG 16 dot layers. So what we have to do, we have to do layer dot trainable is equal to false. So we have not to train all these layers. Let me define x is equal to flatten VGG16 dot output. Then prediction will be equal to tens. We have 4 different categories, and our activation function will be, you can say, softmax x. So model, so let's define this as model 2. Model input will be our, you can say, inputs will be our this input layer, that is VGG VGG16 dot, you can say, input, and outputs will be our prediction. ras dot layers dot set. So you can see it is. Now we can see its we can see all layer also. You can see now we will training our model. So first we have to define model. It is model 2 dot you can say compile. So here optimizer will be, you can atom, and loss function will be categorical cross entropy, and our matrix will be accuracy. And we will use model 2 dot fit. So we will fit on our X train, Y train. So epochs will be, you can say 50. Valuation split will be 0.2, and batch size will be 32. I guess we need to, and one is callbacks for early stopping. Now let's start fitting our model. Again we have to copy this and write them. So you can see in our third layer, we approaches to around 93% accuracy because all our previous layers are already pre-trained. Till then, let me do one thing. Let me create a new repository. We will give the image brain tumor classification. And here, let me create my brain tumors classification. Also, let me check this. You can say image data size. If it is of large image, okay, so it is of around 60 MB. So we can upload this in our Git. So we initialized our Git. Now what we have to do? Git add. So it is trained. Let's calculate. You can see we are getting around 86% accuracy score. And in our, you can say, first model, we are getting around 88% accuracy score. We can try two other models also, that is Inception V3 and ResNag, ResNag 50 also. Let me first. Okay, this is of, you can say, a large size. That's why I think that's why it is taking so much time. Till then, let's. So I think this is enough for today. Tomorrow we will work on our, you can say, train our model using Inception V3, you can say pre-trained model, and Resonant 50 pre-trained model. So thanks for watching.